the horizontal component of the vector, the vertical component of the vector. The horizontal component is going to be this R, okay? This R cos. Okay, so it means that X is going to be R cos theta, and then the vertical component, and it is going to be that's R sin theta. R sin theta. Okay. And you know, we said that red is S I know. Okay. So we can substitute what F is. F is actually R. But again, I hope it will not distract us like this.
No, sir.
So it will performing. So Z is R into. Is this what we are talking about? Yes. Just get the vertical component and the right component, and then you do this substitute. And then you have R cos theta plus I sin theta. So this is the polar form. Okay? This is the polar form. So if you do Z to the power n, means Z squared, Z to the power 3, you can as well raise this to the power of n. In Z n, this n. You can do any algebra with it. Yeah. Okay. So you're going to have the whole of R cos theta plus I sin theta or to the power n. Okay, so it still makes sense. You have R to the power n. I hope you understand that. That if you have x, y to the power, say 2, this means x squared y squared. So it means you have Rn, then cos theta sin theta or to the power n. But that will mean Rn cos n theta plus R sin n. So, you can even take the fractional power of it, 0 to the power 1 over 8. Is that right? So, that is that about that. The assignment I give you, let's see, let me mirror the end fruit. The end fruit, we have if the v raised to the power and then it means that W, if W is the complex number and if you raise that W to the power of n, it means that W will be 0 to the power 1 over n. Do you understand that? I want response to this. Do you understand that? Do you understand that? No. Okay, what should I use now? Let's say we have, if I do 2, let me use, if I do 4 squared, what is 4 squared? 16, right? So it means that 4 is going to be square root of 16. You understand that? The same thing. The same thing, because all we are saying is 16 raised to the power 1 over 2. So, I write W raised to the power n and it's Z. It means that W is Z raised to the power 1 over n. So that gives the nth root. Because that gives the nth root here. How many roots will you get here? 2. So if you have this, W raised to the power n, Z, then the number of roots that you get for this algebra is going to be n number of. That is why we have this. So we write Z is 1 over n, but then n to start from 0, isn't it? N can start from say n equal to 0, 1, 2, 3. So when n is 0, you know what we have. It means Z is going to be 1, or W is going to be Z. Are we okay? Is that all right?
Yes, sir.
So I was trying to do ask a question, I quickly want to z to the power n. So z raised to the power 1 over n is now defined to be r cos theta plus I sin theta raised to the power 1 over n. Are we okay? Just the same thing that we have done here, where we have 0 raised to the power 1 over n is r raised to the power 1 over n, r raised to the power 1 over n cos theta plus 2 ki 2 ki over n plus I sin theta plus 2 ki over n. So you expect that, as we did for here, that we should also have cos theta over n, isn't it? It will just be cos theta over n, but we can have more, we can have more flow. You don't understand? You don't know it? It's supposed, if you want to do it like this, it's supposed to be this way, cos theta over n, right? Cos theta over n, sin theta over n. But you know, we are dealing with trigonometry. There are cycles, and one cycle is 2 pi, isn't it? What's one cycle? 360, I mean? 360 degrees. Is 360 degrees the same thing as 2 pi again? Are we following? 360 degrees is 2 pi again, and that one cycle we can have multiple of it. So let's say for case. So case started from 0, 1 to 3. So we can, so for the cycles now, we can put 2 pi k. Okay? 2 pi k. This is how the n is defined. And I will quickly state the Euler's formula. Euler's formula. Euler's formula. I'll just state this formula first. X is, if we take x to be I theta, okay, so it means that e raised to the power I theta is going to be cos theta plus I sin theta. Are we there? So that that implies that we take exponential of z, which will give us exponential of x plus iy. This means e raised to the power x times e raised to the power iy. Are we there? But this is a complex number. We can write e raised to the power x. It will be cos y. It will be cos y plus I sin y. So that's the Euler's formula. You've been taught all this one in honor level. I'm just trying to follow. After this now, we move to functions. We move to functions, and then we can do limits. So thus, if we have e to the power I theta over n, that will be e I n theta. So that's by the Moivas theorem. So by the Moivas theorem, we can take our z to be r z is given as r e raised to the power I theta, because e raised to the power I theta is exponential I theta is cos theta plus I sin theta. So for us to have a complete Z, there must be a R, isn't it? So it means Z is R is for I theta, and then it implies that Z is for N will be defined as R E I theta raised to power N, which is R raised to power N E raised to power I N theta. Are we okay? Any question? Any question? So let us revise this. We don't do the dot product and the vector product. If you take Z1 to be X1 plus say I, Y, Y1, and our Z2 to be X2 plus I, Y2. Z1 and Z2, they are vectors. They are vectors. So it means that the dot product, the dot or scalar product, is defined by Z1, Z2, and that is simply the modulus of Z1, modulus of Z2. Yes. Yeah, that is why every bit I say that I write, I say it, so that people that cannot see can hear. Okay, my handwriting is. Am I fast too? I'm fast. Because I'm just trying to lay foundation here. This is not today's work. Is this one a biggie? So what can you not see? What can you not see? No, sorry, it's because the board, I don't know if they used it and they not clean it. I clean it now. Thus, exponential I theta, e raised to power I theta, that gives us e raised to power I n theta, of course. And then the Mober's theorem gives us this, because since e I theta is cos theta plus I sin theta, then our z will be r e I theta. Because our z is taken to be, can you see this now? Yeah. Okay, I'll write it r cos theta plus I sin theta. That's our z now. So it means that since this is the e I theta, means our z is r e I theta. That is what we have here. Okay. And Zn is R and E and theta. And here, can you see this one? That if we take two vectors, two different vectors in the complex way, Z1 and Z2, Z1 defined this way and Z2 defined to be X2 plus I2, then the dot product or the scalar product is defined to be the product of their magnitude, then cos theta. Okay. Cos theta, where theta is the angle between Z1 and Z2. So here theta line between 0 and 2 pi, okay, is the angle. What is this angle right now? Here. Okay. Between Z1 and Z2. The angle between Z1 and Z2. The cross product. So giving Z1 product is given as the cross product is defined by Z1 plus Z2, Z1 plus Z2, and that is given by modulus of Z1, modulus of Z2, sine theta. Okay, so we want to discuss what function is. How many of us have not done function before? Can I do it? How many of us have not done function before? Great, nobody. So we are moving on to the next subtopic, and that is the functions of real. Functions of real variable. Who can tell us what a function is? I don't know people's name, but I can call it. I only know one person's name, but I don't want the person to feel intimidated. So I will not call the person. Okay, let me see. I know many people in this class now, but not by name. Not by name. If you use phone, I will collect your phone. If you use phone, I'll collect your phone. So that when you are going, you come and collect it. So who can tell us what a function is? Sorry, why are you frowning your face? What happened? Talk now so that you're not practicing the exam and test. Eh? Speak now. You have a question? This is where you can talk to. Are you afraid of them? Okay, let me encourage you that personally, if I'm in a class like this, I sit in the front like this. Thank God I'm not big and I'm very short. So I understand myself. I will be in the front. And nobody in the class can stop me from asking questions. I have fought in class before. Not physical fighting, but I have questioned somebody seriously before in class. I said, this professor is teaching us. You pay school fees, I pay school fees. I don't know how you got yours. Getting my home was not convenient. I am now in the class. The teacher is teaching all of us. I didn't understand, and you are restricting me from asking questions. You cannot stop me. Because I asked the professor question, and the boy was like, meaning that I have come again, because I'm always asking questions. He has come again. You try it again. So don't be intimidated. Ask a question. Your school is born like that. So who will define function for us? Oh, function. Anybody? What's function? I will call somebody now. People are hiding their faces. Don't do that now. You need function in order. How many of you did the 1-to-1? You are denying again. What I need are the bits. I need you did it. And I have the record, and you are still saying you did not do it. What is a function of real variable? Okay, what's the function anyhow? Okay, I want to call a lady. Why did you take away your face? What's the function? Anything you say is correct. What's the function? Anything you say is correct. Yes. Is she correct? Is she correct? You don't hear her. She said a function is a map that takes members of a set to another set. She said from the domain to the codomain. Is that correct?
Yes.
So a function is a map But all maps, not all maps are functions. You understand now? But a function is a map that takes the set of numbers. I mean, this is a set of numbers. So it can be anything, but the code domain must be a set of numbers. Are we okay? So we have that idea. I don't know. We do not. Can I clean this now? Yes. I don't want to go here. Normally, I'm not supposed to treat this one because we don't to save our time. Functions. So I will not go in depth, okay? The function, can I dictate? Can I dictate? If variable y equal to f of x, you have seen this before. Don't say come back, there's no come back. There's no again, there's no rewind. A variable y equal to f of x is said to be a function. It's said to be a function of x. It's said to be a function of x if to each value of x a variable x is said to be a function of x if to each value there corresponds a definite value of y. There corresponds a definite or unique value of y. So that is, we have a function defined this way that takes x to y, okay, such that it takes every member of x to a unique member of y. Y, and we say this is f of x, okay, that is exactly our y inside y. Are we there? I don't know drawing set and set, so we are advanced. Example, let the domain of x be the domain of x as a domain of the function is defined to be, if I give some set of number in the domain, say -2, -1, 0, 1, and 2, okay, assigns to each value, of x the number y equal to s. You know actually that for each value of members of this domain, if we insert them into this function, we get another set of numbers. Is that correct? So, and what will be the set of the range now? This set of values, this new set of values is called the range. It's called the range of the function. It's called the range of the function. So that is, we're going to have R could be, let's say, the range of f of y is going to be -2 raised to the power 3 will give us -8, isn't it? Are we together here? Are we together? Why? But we are in the same room now. We are not doing anything here, we're just talking. We are not doing anything. What we are doing is, there is a set A taken to set B. And the function that does that is this. and that function is defined to be x to the power 3, and then we have members of this domain. Minus 2, minus up to, it's an example. Okay, it's an example, minus 1, 0, 1, 2. Then what will be the member of this cell? The member of this cell is what we call the range. What we call the range. If you put minus 2 into this function, you're going to get minus 8. That's what we are saying. If you put minus 1, you get 1, minus 1. If you put 0, you get 0. If you put 1, you get 1. If you put 2, you get 8. So that all we have is 1. If this is the domain, then this will be the range of the function. Are we okay? Are we okay? Yes. So, thank you very much. So please, you have done function before. Let's let me give another function. Example. A function. An example is, let's say y equal to, I can write cube root of say x squared minus 2. This is a function. Okay? Some types of function, some types of functions. I will not mention the classification here. I will not mention the classification of function, one-to-one, subjective. You have known what is one. Subjective, one-to-one. Let me ask a question. Is the domain of the function always equal to range? Is the domain of the function always equal to the range? I mean, codomain rather. So when do we say the codomain equal to range? When do we have this? When the function is no. What does it mean that a function is one-to-one?
If every element in it has a unique image.
Has a unique image, just to map to only one element. So it does not mean that does not guarantee that the codomain will be the same thing. The range is the set of members of B that has the image here. Is that clear? But you can have more members of B that do not have the image in this list. So in that case, you have more members here than you have in this list. Do you understand? So the whole set of members you have here will be your codomain. But the range will be only ones that have the image in this list. So the codomain will become the range of the same thing as the range if the map is onto, if it's subjective, that is every member you have here has a unique image. That is when you say that the codomain and the range as it says. So let's look at this. We can have number one, zero function. We can have a zero function. Okay? An example of that. Example is let me say that is if the function of x is equal to 0. When the function you define is 0, then the function is a zero function. It is zero function. And I can give you this example. Example, if f of x is equal to x cubed minus 2x squared minus 5x plus 6. This is a function, right? If this function must be a zero function, then we have equal to 0. And when we do this, it means that we can actually obtain the zeros of that function. Isn't it? You have done that in polynomial. I have not done polynomial before. Great, nobody. You are okay, you are here. I've seen you like that. I've seen you. Okay. So how do we obtain the zeros of this function?
Assign a value to this.
You
You
know?
assign a value to x.
You assign a value to an error,
Yes.
and then you use your maybe long division to reduce the order on the if it's quadratic now, it's easy. You check it. We did quadratic division last month. Yes. So I believe you can do this. Even if the order is up to 10, you can do that. You can always reduce it and find the zero of the function. So here, the zeros are 1. You will get 1 minus 2 and then 3. Okay? The zeros of this function, that is the result you will get by solving this equation when it equates to 0 is going to be 1 minus 2 and 3. What it means for the function to be 0 is, let's say we have this. You know, this is y axis, and this is what? This is the function. This is y. This is the function of x. Taking value from it. So it does not matter. Okay, for this now, this will be something like this. So the function has the value here. That's the highest. And the minimum is going to be here. Isn't it? So, and this is 0. The function will be 0 when you reduce the value, when the value is, whatever we get here is going to be 0. And that will be exactly 3.1, 2, and 3. You don't get it? No. For this function, you will get something like this. Is that right? You will get something like this. If it's 4 now, at 0, you're going to have 4 points on the x-axis. Isn't it? Because if the highest power is 10, then you get n number of zeros. If it is 2, you get 2 values. Your quadratic equation, yeah?
The y-axis is the function.
The y-axis is the function.
Then at 0, you have those are tables.
At 0, you are using the function to 0.
Yes, so those
Then
are
it becomes a function.
all the points on the x-axis is the values at the function equals 0.
They are the values. At this point, that is where the function actually intersects the x-axis. That is why, so at 0, this is the value function. So are we, any question? Any question? You have done all this before now. Then we can have even function. Mark. This part. This one. I didn't solve it. No, I just give it as an example. The function and you can write it later. So, even function, we say that a function is even. Please, I don't want to write anything because of time. A function is even when you have f of minus x, it will be the same thing as f of x. So this negative value is not affected. An example is the cosine function. Cosine function is an example of that. Then you can have odd function. Odd function. We have odd, we say a function f of x is odd if f of minus x is minus f of x. I think these concepts they are cheap, isn't it? If by having f of minus x, what you get is minus f of x. But it will be even if when you take f of minus x, it is still same thing as f of x. So an example here is the sine function. E.g. sine function. Okay? Then we can have bounded function, number 4. Bounded function. A function is said to be bounded above. What is that now? And below if there exists real numbers n and n such that the function of x is less than n and let me use all here. Or if f of x is greater than or equal to n. So this function is bounded above. If when you take the absolute value of that function, that exists a number that the absolute value of that function cannot exceed. So it means that this function is bounded above. Then if this happens, it means that it's bounded below. We have expressed something like that for set for bounded above, bounded below. For a function, you take the absolute value. If when you take the absolute value of the function, there is a number that terminates the value of the function at the upper hand, say n, then this function is bounded above, this one is bounded below. Okay? So then, what do we call these numbers? M and N. We call them what? They are real numbers. They are upper bounds and lower bounds. So they are upper bounds. Lower bounds. So the numbers n and n are called so this will be the upper bound. Are called the upper bound. Upper bound and lower bound. Respectively. Okay, so let's look at this example. Example, if I give f of x to be x minus 1, 5 minus x, for x it is open interval 1 and 5. So what are the values of x value? In that interval, what are the values of x? 2 to 1, 2, 3, and 4. Yes, 2, 3, and 4. So it means that we just look for f of 2, f of b, and f of 4. So if you do f of 2, what do we get? So this is the same thing as 2, 3, f of 2? What's f of 2?
3.
F of 2? 3. Okay. F of 2 will be 3. F of 3? F of 3? 4. F of 4? F of 4? 3. Also 3. So we say that, so we can write that this, you see, within this interval, the value of this function, because this is the least number, f of 2 and f of 2, okay, takes value from, 3 and 4. So we can write that the function takes, in this interval, it takes value from 3, f of x takes value from 3 and 4. So if we define a larger interval, okay, you can always do this. Always do this. So let me not make time with that. How many of us have not done composition of function before? Composite function. You have done it. Okay, let's talk about it briefly. I'm looking for G O F that takes a C direction. Okay? And for example, as an example, I can define a function f of x. Wait, it appears to me that people are writing assignments instead of presentation in class. No more solution. Yes. No. We said 5 minutes into the class, we collect. And this is how many minutes you want?
Work class, nice one. Yeah, no.
So you were not listening before, Abby? Okay. Wow. What do you want to do? You want to look at me? Please, nobody should call again. So it means that I was doing drama here. You're not listening. Okay. So let's define a function f of x to be, let's say we have x squared and g of x is x plus 3. Are we together? G, this composite x onto, it will compose these two functions together. So that you are going to have x squared plus 3. And you can also have f compose g, you can have g compose g. So this will take x to x plus 3 squared. Do you know how this happened? Do you know how this happened? This okay. So this one takes this into this. I follow you. So it's like writing. This one is like writing. And this one is like writing g of f of x. That's what this one is. Okay. And this one implies f g of x. So you are putting here. You are putting f inside g. Wherever you see your x in this case, whatever is the definition of f replaces x in this case. No matter how large or how small it is, everything you have here becomes a point inside g. Did you understand that? Did you understand that? And that's x squared plus 3 and x. Let me see if I can give you an example. Example. Let f of x be 2x minus 1 and g of x be 3x. 1. Okay. Find 1 g compose f and 2 f compose g. So can you do that? Are you doing that? Are you doing that? Number one, we can what is the answer for number one? 6 minus 1. Okay? Because this is g f of x and what's our g again? 3x. So we are putting f of x inside g. So whatever you have here is a point here. So that is 3 times x. And your x is 2x. So you have 6x. Then that's 1, 2, f compose g. Is, that is f g of x. That is 2x. And your x is 3x. 2x. Minus 1. And that is what? 6x also. So you see that the composition of function is not always the same. Exactly. This implies that composition of function is not completing. Do you understand that? Yes. Like this. It is not always true. It's not always true. That is the implication of that. Let me give this as exercise for 30 seconds. Exercise. Let h of x be defined by two x squared plus 3 and okay. And let g of x be exponential cube of x squared minus 5. I am doing this deliberately because showing you simple functions, you feel like that is all. That's not all. You can have a more complicated function and handle the same way. Is there a problem with this place? Okay, find the first one you are looking for, h compose g Set that. So what's the answer for the first one? I don't have the answer here. If you don't do it, take it home. You will take it home, right? I am leaving function like that. So go and do more on the functions. Let's discuss limits of functions. Limits of functions. Today is the third, or this week is the third week, right? Second or third? By your own calendar is the second. By the university calendar is the third.
Yes, sir.
Sorry. So can I do this please? Or clear that? I don't like this. Limit of function. Limit of functions. Are we ready?
Yes, sir.
Someone said me. Are we set? Please, let me tap into this window. Where's your name? Can I see your name? That bar is empty. You are busy with your phone. This thing is almost empty. Almost empty. Okay. So please, let's look at this graph. For example, if, or let's say for instance, if we have this graph, X and Y, and then I can find any curve. Let's say, okay. Let's say if I pick a point A here, a point A, and I define any function. Let's say after plotting the graph, if we have something like this, are we there? So the value of A here, the value of the function here is on this axis, is here, right? The value of this function f of x at this point on the x-axis is this value here. And let's call that value, let's say, here, okay? And then let me shift my hand. Let me pick this point, A, then the value is there, okay? And you know, I can add a small number to this A. Let's say a delta. If you add a delta to it, then it shift to the right. So you are going to have A plus a delta, isn't it? And then the value here become, the value here will also change, also shift, okay? And then you have L plus what? Let's call that, let's give that number, let's say epsilon. Are you okay? Then if the number that I added here, if I subtract it from here, I will have A minus delta. Then the value of the function here is okay, L minus delta. So that this becomes an interval. So if in this interval now, the value of x, you know, all these ones, A minus delta is a particular value of x. Isn't it? It's a particular number. So if any value of x is picked in this case, I as the value is approaching this A, the value of the function will be approaching L. Isn't it? And if I can also start from there, pick some number, as the number is approaching A, this value will also be approaching L. But they may have similar value at the end of the day, or different value. So the limit as the function is approaching A from the right may be the same as the value as the limit is approaching the left. And sometimes it depends on the function, they may not be the same thing. Do you understand that? They may be the same or they may not be the same thing. So we define the limit. So we say that definition. I did so that you can see the picture. A real number L, okay? This real number L is said to be the limit. This number L is the limit of a function f of x if as x goes to x naught, as x goes to x naught, here we assume that whether from the right or from the left, it's the same thing. If not, you have to be careful that maybe as x approaches A from the left, or as x approaches A from the left, from the left. So if it gives you the same thing, just simply conclude that x tends to A. So as x tends to, let's say, A or x naught, all the same. For any epsilon positive, there exists. If there exists, so as the function is approaching L, for any epsilon, there exists a delta, okay, that is also positive, such that the distance between the function and the limit, that is f of x minus L, will be less than epsilon whenever we have the distance between the x and the point A is also less than delta. Any question? Any question? You don't understand? You don't understand? This is saying that the absolute value of the distance between the function and this particular number L, the value will be less than epsilon that you choose, or that is given you. If, when we take the distance between the point x and the point A, is also less than the delta that you obtain. How can I explain this again? Let's see. So let's say for example, if I pick, let's say function f of x, I don't know. Let's say for instance, if we take the distance between this function and L, if the value is less than epsilon, it means that any function that any point that you pick here, if you take the distance to less than epsilon delta. Okay, alternatively, you can write this as we can write limit as x tends to A. So limit as your x, as the point you pick is getting to A of the function of x is L. So it's the same thing. It's the same thing. If you want to specify whether from the right or from the left, you say limit as x tends to A positive of f of x is L. That is from the right, that is right. Then limit as x tends to minus of f of x is, I would want to use that. I want to use another number. Let's say, give me a number now. No, give me a number. This is a number L. Give me another number. L, Mari. Okay, P. Number P. So this one from the left. So if L and P are equal, then it means that you can just write x tends to A equal to of f of x is either L or P because it's the same. So that's what we're doing. So let's look at this example. I don't like that side. Can you see that side? Can you see from that side? I'll come back here. So let's look at an example. You have to show that maybe I will give another problem that will stop you. Do you want? Do you see this? You have to show that this is true. That the limit as x approaches 1 of this function is 3. So if you are given this, you are expected to use this definition to explain. Do you understand that? Somebody cannot hear me. Sorry, that lady at the back is pressing phone. Yes. Does she have a note? Do you have a note? Yes. Do you have a note? You have a note. Can you bring it? Okay. So can we attend this problem now? You know, by this definition, do you see this? So just identify your f of x, L and L there. Your f of x is 4x minus 1. What is your L? What's our A? So you know it now. So we do f of x minus L, alright, and this will be 4x minus 1, then minus what? 3. So can we break this down? That's 4x minus 4, right? Minus 4. But this means that this down here means that x minus 1, that is our x minus a, and delta, by definition. Are we okay? By this definition, that's what we have. X minus 1 is less than delta. So that whenever we have x minus 1, we can take it as delta. Oh, I got minus 4. Okay, here now, 4x minus 1 minus 3. So we can write this as 2 into x minus what? X minus 2. This is equal to no. We need to use 4, right? Because the circle we have is minus 1. That's 4 into x minus 1. And this is same as modulus of 4 and modulus of x minus 1, isn't it? So what we have is 4 delta. Are we okay? So what should be our epsilon? So we can take because this should be less than 40. We are assuming this. So we can take epsilon to be let's take delta. Delta, we are seeking for delta, okay? So what would delta be so that we can have this less than epsilon? Are we okay? Let me simplify this, and at the end of the day, we must get epsilon in this case. So for this to be epsilon, we need to take delta as say epsilon over 4. You understand? So that if we do that, we get we're going to get 4 times epsilon over 4, and then you get epsilon. Do you see that? So it means our delta that must be chosen must be epsilon over 4. It's just from where? From here? From this place? From up. From up. F of x minus L from our definition. From our definition. F of x minus L. What's our f of x? Minus L. What's the L? 3? Okay. If we expand this, do we have this?
Yes.
Does this one give us this?
Yes.
Does this give this?
Yes.
How?
Factorization.
Factorize now. Factorize. Can you factorize?
Yes.
If you factorize, what is common to this and this? No. You bring it out, then solve that if you open this, get what? Get it back. Then if you take the absolute value of this, here should be something like less than or equal to. Okay? If you take this absolute value, you can break this absolute value on the product. This absolute value of 4 and absolute value of x minus 1. But absolute value of the positive number is positive. So it's still 4, and we can take this as delta. Are we okay? So we have that. This gives us a 4 delta. But we need to get less than epsilon. Isn't it? That is what we should get. What we should get there should be epsilon, not 4 delta. For us to get 4 delta here, what is the value of the delta we can choose for us to achieve this delta? And then what we can do is to let this be epsilon. Are we okay? Just say 4 delta. What I claimed was correct. Just say 4 delta equal to epsilon, because that's what we want. Then you can make your delta. So if you choose delta to be epsilon over 4, you have 4 times epsilon over 4. Question?
What are the conditions for choosing the value of the conditions for choosing the value of the
I think the
simple like the condition for choosing the value of the delta.
how do you mean?
Like, why is it over 4?
Why is what?
Like, can it just be epsilon over 4? Is it because when you arrive at epsilon, that's why you choose?
By definition.
It has to be less than epsilon.
By definition. So you are solving that by definition. Are we okay? I will give you more examples. By our time. So let's look at algebra of units. So because we are able to satisfy this condition, it means that this is correct, actually. Okay? Before I give more examples. Let's look at other problems of limits. Other problem of limits of functions. Number one is limit as x tends to some a of f of x plus g of x is the same if you are taking the limit of sum. The limit of sum, it is the same as taking the sum of the limits. F of x plus limit as x goes to a of g of x. You can give a small example here. Like evaluate limit as x goes to say 2 of x squared plus 2x plus 3. This is like what we have. So what that means is we are taking limit as x goes to 2 of x squared plus limit as x goes to 2 of 2x plus limit as x goes to 2 of 3. So it means that you can evaluate the limit term by term. You have a question? I do. Term by term. So this would be, 2 square, right? To evaluate this, just make a substitution. Always make your substitution except it fails. Except if it fails. It can fail. Direct substitution can fail many times. So if it fails, you can another. So this will give us 2 times 2, right? Plus this is still a constant as 3. So we have 4 plus 4 plus 3, and then you get what? Sorry. 11 for that function. So this same rule is also true for subtraction. I don't want to waste time in doing that. Okay? It's also true if it is subtraction. Yes. If the example is minus values, then the same thing. Okay. Number 2, limit as x tends to a of any constant is constant. That is what happens here. Then 3, limit as x tends to a of the product of functions. Let's say you are multiplying two functions f and g, taking this limit, it's taking the of the limits. X goes to a, f of x times limit, x goes to a of g of x. Hello. Did you take it? Then we have, if you take the limit as x tends to a of quotient f of x divided by g of x. Okay. It is the same thing as the quotient of the limits. S goes to a f of x over limit as x goes to a of g of x. But in all the cases, your g of x must not be 0. Because if g of x is 0, that's a problem. It's not will be defined. If that happens, you must look for another way of solving the problem. Okay? Not that route.
Yes.
Also, maybe you can look for example. example. 1. Look at this example. Take the limit for the product. For the product of functions, we have two different functions here. We have the exponential function and the trigonometric function. If you are to take the limit as x tends to 0 of the product of those two functions, what would be the answer? What is the answer? 1. So I'm happy like that. It's like everybody will get me in this class. Oh, ye of little faith. Where's your faith? I am declaring positive. You are your faith of comparion. So this means limit as x tends to 0 of e raised to the power x times limit as x tends to 0 of x, and that is e raised to the power 0 times cos 0, and e raised to the power 0 is 1 times cos 0 is 1. Some other problems will not be this cheap. People ask me. Let me see if I can. I got that from my hair. Let's see if I can get something. I am careful to bring these examples because we have not discussed some things. Okay? So let's take example number 2. Evaluate. Limit of limit as x tends to, I'll bring this, okay? Let me bring this. As x tends to 2 of x squared minus 7x plus 10 divided by x minus 2. See? So it means that you can take the limit as x tends to 2 of the numerator and then limit as x tends to 2 of the denominator separately. Over 0 is what? Eh? I have seen it many times, plenty. Plenty. It's not true. Anytime you have, see, look at what we did here. This G of S will not be 0. If it has your ratio becomes undefined, your function becomes undefined. So you say if you have this, it's undefined. It's not even infinite itself. It is simply undefined. So you must look for another way. If you have this, after substituting and you now have something like this, you must say, and look for another way. One of the ways is that you can look at it if factorizing the numerator will help you eliminate this denominator. You understand? We have discussed two methods now. One is just substitute values. If you don't want to any trouble, go. But if there's a problem, you must come back and look for another way. And one of the ways is try factorization. Like here now, what we have is a quadratic equation. It may be cubic, it may be any other function. If you can factorize them, then see if this one will go. I think they can do this, right? This is is it minus 2 and minus 5? Yes. Minus 1 minus 5, yes. So we can write this as limit as x tends to 2 of, after this being said, I don't want to see 0 over 0 equal to 0. Did you hear that? Yes. Anyone that does that will find the person, you will pay. Do you agree? You will pay. You know, we're going to have x squared minus 2x minus 5. Then, so that this gives us x minus 2 minus 5 into x minus 2. So the factors are x minus 2 and x over x. So this will go. So we are left with limit as x goes to 2 of x minus 5. And then if it's substitute now, we have 2 minus 5. And then, so the answer is not the answer. It simply means that this function is undefined at 2, or it has a dumb continuity at 2. It is not defined at 2, but you can dodge it. You can find your way around it. So it has a dumb continuity at 2. It is not continuous at 2. Dumb. I hope I'm not rushing too much. What did they say? A polynomial, the denominator. This is polynomial. You will look for a way of factorizing it. But because we don't have time, there's something we are taking here. You can also try the logical rule. That's logical rule. Okay? The logical rule says that if you have limit as x tends to a of f of x, because most times that we have undefined functions is when we have rational functions. This does not work. If this one gives you 0 over 0 or 0 or infinity over something like this, what you should do, this will be the same thing as limit as x tends to a of fn of x over gn of x. That means you can differentiate this. If by the time you differentiate, if what it gives you is okay, does not give you problem, no undefined function, then you are good to do. If it gives you that same problem, differentiate again until you are done. Yes, please. Can I think of an example now? Let's say you have to evaluate limit as x tends to 0 of cos x. Limit as x tends to 0 of cos x. What is the answer? One. How do you do that?
The x is 0.
So what is cos 0? You have to show it now. You know you can write this as x goes to 0 over that's cos x over. Do you know? Yes. So if you put your zeros, what do we have here? We have cos 0 over sin 0. And this is 1 over 0. But this is undefined. So let's see if you differentiate this and differentiate this, if you are going to circumvent this problem. So differentiate cos x, what do we have? minus sine x. Differentiate is what we have. Cos x. So let's put our 0 again. You put your 0 again, you have minus sine 0 over cos 0. And then we have, what do we have? What is sine 0 now? What is sine 0? 0 over what is cos 0? So the answer is not 1. I use this as an example. You can have more function like that. Once you have 0 over 0, you have 0 at the middle, you can apply this. You differentiate up and down. So I think everybody solve this now. I want a guy to give me this answer from the back. A guy to give me the answer from the back. Are they changing seats? Don't change seat though. Oh yeah, evaluate. Number 1, limit s to 2 of x squared plus 4 over 3x plus 6. What's the answer from the back? What's the answer from the back? Are you a guy? Limit as s equals to 2 of 8x over 6. The first one for a guy, the second one for a lady. A guy from this column. Who said 2 over 3? Who said 2 over 3? Come and show us. Come and show us now. Come now. Anything you write is correct. Come. Anything you write is correct. Is that correct? Okay, ladies should come for the second one. You said? 4 over 3. 4. Can you show us? Whatever you want. You differentiate. She said you should just differentiate. If you put 0 here, what do you get? know what I'm saying, no? Don't put and say 0 over 0. Answer 0. You go. You have marked yourself. Don't do like that. Don't do it, though. So, you can just differentiate, use the doctor rule, differentiate this, differentiate this. Then you get 8 over 6, and then you get 4 over 3. It's too cheap, I mean. If you want to go in the long way, you can use the, okay, right? This is not what I want to write here. It is not what I wanted to write. I intended to write tan. This is my intention. This is what I intended to write. Okay, take this one as homework. Let me change it. Homework. Assignment number 1. Let me change it to sin 8x over this one. I have given you one assignment too. Sin 8x over x. Forget that one. Limit as x goes to 0. And 8x sin. No, that's the follow one, I think. Because once we leave limit like this, we are going to sequences. Sequences. You know, we don't have the time to waste. Any idea? 1 over 6. Which one? This one? Said 1 over 6. Yeah, let's confirm. What did you do?
I got 4 over 3.
You got 4 over 3? 4 over 3. Okay. Any other answers? So what did you do? What did you do? Where's the guy now? Michael. There is something I want to do. Okay, let me leave this one. Let's look at this. 6x sin So let's look at that problem. Yeah. Okay, this way. If you use lopsided rule, it will work. I will keep. But I want to do something to explain that. We can write this as, because tan is sin over cos, isn't it? So we can limit as x equals to 0 of sin 6x over cos 6x. That's our tan 6x. Then 1 over sin 2x. But I can write this as limit as x equals to 0 of sin 6x over sin 2x times 1 over cos 6x. So By the algebra of limit, you can take limit of this and then limit of this. So this one, you can write this one as limit x goes to 0 of sine 6x over 6x times 6x over 2x times 2x over sine 2x. Do you see that? This one alone, I'm writing like this. Then times this one is 1 over cos 6x. I have not changed anything. Because this 6x, I'll tell you why I did this. I will tell you why I did it. 6x. This one, take care of this one, isn't it? It's gone. This one too. We are left with only sine 6x plus sine 2x. And that's all. But why I did this is, okay, we now have limit x goes to 0 of sine 6x over 6x times limit x goes to 0, 6x over 2x times limit x goes to 0, 2x over sine x. I'm just writing this for you to understand. Then times limit as x goes to 0 of 1 over cos 6x. So that this guy here is actually 1. This one is 1. You don't need to bother yourself because limit, we have this standard limit, limit as x goes to 0 of sine x over x is 1. Are we okay? And it's also true for limit as x goes to 0 of x over sine x. You still get the same thing. Well, it does not work for cos. So here you have, what is this? This dog is 6x over 3, that will be 3, right? Then this is also 1 times, you put your 0 here, what do you get? That's cos 0, 1 over 1, you get 1. That's 1. So the limit is 3. When x, yes, only when x goes to 0. When x goes to 0. Well, it does not work for cos. It's the same thing for tan. Okay, it works for tan. Same thing for tan. So why I mentioned I cannot list all of them in this class. I would like you to go and okay, let me write it because some people don't do it. Assignment number 2. Yes. Right. This one. Because I knew. Hello. Because I knew what I want to do. I want to achieve sine 6x over. You understand? And then 2x over sine x. And what I can do is to. Okay, that's sine 6x. I force this to be 6x. I have to remove it. The only way I can remove it is to multiply it completely. Isn't it? Because it was not there before, was it there? But I want it to be there, so I put it. Putting it, I have to remove it. And then I'm writing this one to us 2x over sine 2x. This one was not there. What we had is 1 over sine 2x. So putting this one, I have to remove it. Removing it, I have to do this. So we have this. So write out the standard limits. The what? Standard limits. Maybe you should prove them. Standard limit of function. Like Like I've given you this one. You have more. You have more of them. I am saying you should write them out because writing them you will learn. And in the exam, you may need any of them. In the exams, you may need any of them. That is why. By L'Hopital rule. This one? If we differentiate it, right? Okay. No, we did not use we did not differentiate the okay. We did differentiate. We did not use capital rule here. That's why I didn't get you. We didn't use capital rule. We just expressed what tan 6x is. Tan 6x is sin 6x over cos 6x. So L'Hopital rules are not thing. So the time is against us. I don't know if we cannot proceed into sequences, but let's see if I can give you more problems in the limits. I have given you two questions. Assignment number 3. Evaluate limits. Look at what I'm writing here. Limit as x tends to 0 of 10 raised to the power x minus 2 raised to the power x minus 5 raised to the power x plus 1 divided by x tan x. Who cannot see this? Limit as s goes to 0, 10 raised to the power x minus 2 raised to the power x minus 5 raised to the power x plus 1 over x times x times x and x. Let's see if we can be up to 5. Number 4. Limit as s goes to 0, tan 2x minus x over 3x minus sine x. X goes to 0, tan 2x minus x over 3x minus sine x. I will give more. Limit as x goes to infinity, x is to the power 4 sine 1 over x plus x is to the power 2 divided by 1. I hope you can see. Limit as s goes to infinity of x is to the power 4 sine 1 over x plus x squared over 1 minus x squared. We have 1 minute. I think there's still something I have to do. You should know that when you take limit as x goes to infinity, there's a 0 of 1 over x. What is the answer to this? Eh? It is what? What is whatever? Because the answer to this is if you have limit as x goes to infinity of 1 over x, it is going to be 0. Because as x is becoming larger, you are having x is to the power, so it's going to be larger at the limit and the value will be reducing. So the same thing is if it is x to the power n or x to the power n. So I'm doing that because. So if you don't have any other question again, any question please. So in the absence of questions, then we can go enjoy the week. Please make sure you are working on. And there is nothing that says that the problem you solve in the class is what is coming in the test or exam. All these are just to explain the concept to you. If you need more clarification, please do yourself a favor.
Live.